Welcome to the Mimaki 3D Printing Lab with the 3D GD 1800. All right, thank you for joining us today. We are in front of the 3D GD 1800 by Mimaki. This is a large-scale production 3D printer, and I've got Josh Hope, who is our 3D expert here at Mimaki, to talk about this technology and some of the other technology that we offer in the 3D space. So Josh, thanks for joining us today.
Absolutely.
We appreciate the opportunity to speak to you and to our audience. So one of the things we want to touch on today in regards to the 3D GD 1800 is the misconception, and this is similar to what you would see in like a small desktop environment. Technologically, it's very similar to those products that you might find for a couple $100 online, but from a production standpoint and from a scalability standpoint, this is a completely different approach to 3D compared to what most people think 3D is.
It's actually got a lot of similarities to it, but it's built off of the idea of the small 3D printers that everybody's familiar with. But instead of having an FDM, which you might be familiar with, so fused deposition modeling, where you've got a plastic filament, you're feeding that through a heated nozzle, kind of like a glue gun, if you think of it that way,
right.
And then it cools to a solid. We're actually jetting out a gel here, and we are using a nozzle as well, so we are layering up and laying down the material in a similar way, but it's actually a gel that's coming out of the nozzle, and then we're using our UV curing technology, similar to what you've seen on our flat bed or roll-to-roll UV devices, to turn that gel into a solid.
Very cool. So I think when people look at 3D, they think of 3D as the little plastic component deal. This is a different approach, and some of the things that we've noticed specifically with this one is the way it builds. So it's obviously putting out a larger capacity of the material before it's cured. So when the small ones, they tend to have more infill or support structures, but this one doesn't necessarily need the infill, so it's able to produce a lot quicker because we're able to do more of a shell print as opposed to a print that requires a lot of infill and
yeah, we can actually do it both ways, right? So you have a lot of flexibility in what you want to do. So if you're doing a really complex geometry, you can use infill to create an internal structure. But for most things that we print, you don't need that. Because we're using a gel, we're able to have a large amount of overlap without needing that extra support on the outside edge. So that gives us a lot more ability to print or to make more complex objects without having to go to that infill. So that saves you time, it saves you money, and you still end up with a product that's very durable and rigid and able to go to a large scale.
So let's talk about the lack of infill, because I think that confuses some people, because there's a lot of information out on the internet, there's a lot of videos, but most of them are catered towards that more small format. When you get to this scale, the lack of infill is not it's certainly not a deterrent for capability. In fact, it opens up more range, because now you can choose what you're going to do on the interior, and you can see this particular print that we've got here has got a light going on, so you can use it for backlit purposes, or you can infill it with something more rigid than you would get from a plastic or an FDM with like a foam or a concrete or something like that. Can you expand on that a little bit?
So with a lot of 3D printing technology, you have to use infill, right? And infill is the idea that you're building a matrix of sorts that's inside the shape, which helps to give it structure. On this machine, again, because of our ability to overlap that gel without needing external supporting an object like this, which is, this is a little over 2 feet high, it's about a foot deep, and it's probably 3 feet wide. There's no infill in this at all. It's completely freestanding. It was printed completely free. Now, if we need to do something that needs more structure to it, it's going to be weight bearing or something like that, we can add infill if needed, or we can also go to some other alternatives like foam filling, or we can reinforce with fiberglass after. It really depends on what's the need. So if it's a freestanding object that isn't going to be bearing weight, no infill needed at all. If you're going to something that's going to be going to require some kind of stress that's going to be applied to it, you have a lot of different options on how you want to do it, either using infill during the printing process, or, as I said, foam or fiberglass as a post-process.
And the lack of infill, or the decision to use or not use infill, also gives you the ability to add structural support items in there, like posts or things that you might do in order to assemble multiple pieces if you're doing a larger print that has multiple pieces that need to be assembled out.
Exactly. I think that's what's so exciting about this technology, is there's a lot of flexibility here. So you can decide based on that project, am I going to use infill? Am I going to use foam, or am I going to leave it absolutely as is? You just have a lot of options.
Yeah. So let's talk about finishing for a second, because that comes up a lot. Clearly, with our 3DUJ 2207 and our 3DUJ 553 line, there is a complete color wrap that's generated during the printing process. So that is a full, ready-to-go, fully colored object. In this realm, though, we're only dealing with one color, and it's a single color when it's printed. So there's a finishing process that needs to happen that's very similar to the small desktop. I keep going back to that. Very similar to the small desktop, but this is a different type of finishing process than you would do. You're not going to use like a wood filler traditionally and some light sanding. You're going to do something a little bit more in depth, but the finished product here is much more, let's say, architectural, or much more outside durable, if you will, compared to one of those little objects that you might see a lot of videos about.
Yeah, so again, depending on what you want to do, and as you said, the 3DUJ series, where we're jetting a resin, it's pre-pigmented, we're able to get whatever color you want. In this case, the goal of this machine is really all about scale. And because of that, we're focusing on the single color material, and at the end of the print, you have the option where you can wrap this using Mimaki's 2D printing technology, in the same way that you might wrap a car. You can direct paint these. If you need to have a really, really fine finish on it, you can use a filler such as a Bond or something like that and print in sand. But there's a lot of vinyl products right now that you can put directly onto this and get full color, where you're matching Pantone colors, whatever it might be, and wrap directly to the printed piece.
Yeah, and we've got a couple of pieces that we'll show in the video here today of concept from prototype to production. So let's touch on the 2D again, because I think that's something that people, they see a separation of the two printing technologies. In our world, they're kind of crossed over. There's different paths that they're going on. For a two-dimensional print, for example, you're traditionally talking about a sign shop, or in our industrial product line, more of a manufacturing process. This is a little bit more unique in that regard, in that you're creating architectural, or in the case of the 3DUJ, maybe medical types of printing. But when you get to this side here, you're looking at things like set design, or architectural things like theme parks, entrances to common places like a mall or something like that. But it can go beyond that. It can go into actual production of parts. For example, parts for a car, which we have a sample of, we'll show you. Parts for maybe a boat, which can be complemented by that 2D technology.
Right. And I think that's the key word, right? Is these are complementary technologies. So when you're looking at a sign shop, or you're looking at a company that's already experienced in 2D printing, this is a really great way to kind of start from the outside in and take that 2D printing that they're already doing, and they're wrapping on typical or traditional objects, things like that, and now you have the ability to start building the structure that's underneath that print, right? and use the same experience that you've had matching colors or wrapping contours or things like that, in that, as you said, that gets you into a whole nother world of production, right? So on the prototyping side all the way to the production side, if you're talking about exterior pieces for architecture or even architectural models, the fact that you can see this has, as you mentioned earlier, it's got a backlight to it, right? So there's opportunities for lighting, there's opportunities for aftermarket car parts, there's opportunities for or not just car parts, but also in the automotive world, or in the boating world, or aeronautical world, right? There's all kinds of opportunities there. And because of the fact that you can take these prints and use them as they are at a prototyping stage, or, as we talked about earlier, you can add strength to these parts through fiberglass, whether you're making a mold or whether you're using this as a final use piece, and you can get the strengths that you need without having to go through all the traditional steps to manufacture a part.
With the 3D GD 1800, this is just that next level capability that complements all the other technologies we talked about, whether it's working in a subtractive manufacturing space where you're building some stuff with a CNC milling capability and you're adding architectural elements with this. You can marry some of the 2D technology like wrapping or producing other elements that might be assembled onto this. And also with our 3D UJ series, you can also produce elements that can be complementary to this. So there's a lot of back and forth within the ecosystem of printing, either at this level or at the level of full color that we have on the other side. So the different technologies that are out there, whether you're talking about our full color 3D, which is a UV based, or this, is different than the other processes, but at the same time, it's something that's very familiar.
Right. Very much in the same way that on the 2D side, we have textile printing, we have UV printing, flatbed and roll to roll, we have solvent printing. The 3D world is no different, right? So we've got the multi-material jetting that we use for our full color prints. We have the fused filament printing that we use for our small desktop 3D printing. And then we've got this gel technology. So really, it's about having a lot of different tools at your disposal and looking at the job that you need to get done, and then figuring out which tool or combination of tools is going to be best to get the final output that you need.
Let's talk about the tools for a second, because I think one of the things that we see a lot in this space is the lack of understanding of a three-dimensional software platform. Clearly with a two-dimensional, whether you're using common vector-based software, there's several of them out there, to generate it, you're only dealing with a two-dimensional plane. So you're dealing with a dot, a line, and another dot, typically. Three-dimensional changes that, right? Now you're dealing with an X, Y, and Z capability, and the learning curve can be a little bit more steep. But on the Mimaki side, we try to make it as complementary as possible with the 2D so that it's easier to transition from this to a three-dimensional world. But what are some of the things that you're seeing on the software side that our potential customers would need to know about in order to be successful to get started?
Right. So with a lot of the 3D printing, it's very easy to get an object on the screen that you can spin around and it looks really neat. But then when you go to print it, sometimes it'll just kind of fall apart because the pieces aren't connected, or it's not what we call watertight, making sure that all of the pieces are combined together to make one final piece. Right. So there's a lot of software packages that are on the market today. A lot of them are really geared towards the upper end of the market. So Mimaki has a new cloud-based software offering that's the 3D P3 software program. And basically what that allows you to do is to take a file, you can upload it to the cloud, it will double check the file to make sure that it's watertight, that the walls are thick enough to be able to support the model itself, and basically basically allow a user to automate a lot of those steps, especially as they're learning, to be able to have a high rate of success when they go to output the file. And it's a really great platform that works whether you're talking about the 3D GD series or the 3D UJ series. It will work for any of those, and it's a great place to start.
So the 3D P3 software is really designed to, let's say, offset that learning curve that you're going to have, because you're right. I mean, I can go to any number of different websites out there and download a 3D file, but is that 3D file properly set up in order to produce a physical element in the real world with one of these devices? So software like that helps the the customers even graduate from a smaller desktop up to one of these with a pretty easy to use interface.
Right. It's very easy to use, and for the beginner, it will automate those steps for you, and then as you become more advanced, it's really just a great final check as well. So you can go in, you can do everything yourself, and then use that just to say, hey, did I miss anything? And again, just to ensure that when you print out the piece, you get a expected outcome, and you have something that's usable in the end.
Yeah, and you can use that for the full color files.
Yeah.
When we get into the software, there is really one main thing that comes up, and that's the slicer program. Generally, slicing is done either off onto a PC by itself and then sent to the printer, but in some cases, like the 3D GD, the slicing program is built into the printer itself.
Correct.
This slicer has a little bit more of a advanced capability than others in the market, specifically ones that are on board the printer itself. So you can actually do some model breaking on this particular device. And I want to touch on that for just a second, because this machine has two different print nozzles. So let's say I'm printing a mannequin, a replica of myself. I can print the torso and up with one side of the machine, and the legs waist down with the other side. But most people think of things as upright or in the position that they're intended to be viewed, but with 3D, you really have the ability to lay things down and be more, object-oriented, if you will. So with the slicer on this, you're able to control all of that and really modify the file to be the most optimal for the printing conditions to get the fast through.
Yeah, it's a slicer that is designed with this particular technology in mind. So it knows how the material reacts. It knows that you have multiple heads to work with, and it allows you to very easily take a single model, break it into multiple pieces, optimize it for the bed to ensure that not only are you going to have the quickest print time, that you're also going to have the most efficient print that you can have, and again, the highest rate of success.
And that can be done on a watertight model as well. So when it was previously structurally sound, you can take the slicer and it will automatically make the corrections it needs in order to produce.
Exactly.
Very neat. So let's talk about the RC car project. I know that's something that you've been working on for some time now, and we are really excited about it because it uses all of our different 3D technologies. So walk us through what the idea was with the RC car.
So the RC car is an open source project where it was a car that was designed to be able to be printed on a 3D printer, but to also be fully functional. So it has an electric motor in it, it has servos in it, you'll end up with a final working car. But what we decided was to be able to look at this as a project to say, okay, knowing that Mimaki has multiple different printing technologies, what makes the most sense to be able to use which technology for which part? So the car itself, we used the 3D UJ series in order to get the full color body of the car. We used the small FFF printer that we have in order to do the gears, so we get more strength for the gears themselves. And then we also did some larger pieces on the 3D GD machine to be able to show sort of a prototyping for maybe what the nose cone looks like or what the fuselage looks like, and then tie in the 2D printing to be able to wrap and put the graphics on it, so the graphics on the big piece look the same as the ones that came off the 3D UJ series machine.
So it's an interesting concept for a more or less a sample file, if you will, of what the technology can do. But it's a real-world sample that can be leveraged for prototyping at the small scale. But as you mentioned, when you get to this scale, you can go into production, and the piece that we have to show is a full-size replica of the nose cone of that. So if you wanted to get into like a go-kart manufacturing, you can go from a prototype where you're actually showing the structural elements of the device and the end product, and conceptually how it works, and you can run it through its paces. But then when you get into the full-scale production, you can use the same file, correct?
Exactly, right? So you can start off by using one file, create the nose cone, and print it here. Then you can look at that, have it in your hands, and decide, well, maybe we need to make some changes based off of a particular geometry, the way that it meshes in with another piece of the car, or the overall length specification has changed, so you need to reduce it. At that point, you can then print it again. You can say, okay, well, now we want to show this to our sponsors. They want to see what that's going to look like. You can wrap it in the graphics, so they see their logo on there. They see what the actual color is going to be, what the layout's going to be, and then you can even take it one step further, and you can strengthen the part with a little bit of fiberglass or a little bit of foam, and then that can actually physically be mounted directly on the car, and now you have a final working piece.
That's really neat, and that goes beyond just manufacturing, right? So right now we're talking about an RC car that could be produced into a full replica car or a go-kart or something like that. But you could also take that same concept and go from the small scale to the large scale with like architectural. So I've seen a lot of clients that will do like a layout of what a construction site is going to look like when the architect's done, and you can do full color elements, a diorama, if you will, of that, and then you can also do the full scale elements. So for example, if I had this popsicle in front of a popsicle stand in my finished architectural business park, I could show that with the 3D-UJ, for example, on a small scale in full color, so you can get a visible idea of what it's going to look like, where it's going to fit in the parking lot or in front of the facade, and then you can go to the full framed ready-to-go element that's either going to be backfilled with foam or concrete or whatever.
Right. Again, you've got all those tools at your disposal, right? So picking the right tool for the job, combining those complementary technologies together to figure out, are we at a prototyping stage, or are we just at pitching a concept stage, or are we at a production stage, or are we now at a stage where we need to scale this out to multiple people? We have all the tools to do any of those.
And I think the interesting thing about the 3D range, whether you're at the 3D GD or you're at the 3D FF222, is that you could pick where you are in that conversation. You're either at the prototyping stage, even at this large scale, or you're at the production scale. So there's no wrong way to jump into the 3D lineup, whether you're starting on the small end, the mid, full color, industrial production, or this full scale production like this. So I think that's really complementary of the 3D line itself. But as you mentioned, the ability to also bring in other printing elements from other areas, like our solvent printing, UV printing, textile, apparel, anything like that. Yeah. Let's branch out beyond where we've been discussing. A lot of it's been somewhat signage based, more architectural. Clearly that's where our core competency is as a printer manufacturer. But with this range of products, we're able to get into a lot of new markets, and there's a lot of customers that don't realize in those markets that you can leverage this, because they do see us as more of a sign or an upholstery, textile, printing manufacturer. So let's talk about some of the different market segments that are able to be complemented by this technology easily.
So I think it's been really, really interesting where Mimaki, traditionally being a signage company or signing graphics, the fact that where I think Mimaki kind of thought that our 3D technology was going to be used, it's been very, very different in reality, right? So we have hospitals that are using the 3D printing for doing very accurate, full color, photorealistic pre-surgical models, right? We have toy companies that are using the color printer to do prototyping for toy runs, and we have other toy companies that are actually making collectibles, so they're actually outputting final use pieces on the machine as well. In addition, we've got people that are using Mimaki 3D printers for industrial prototyping, for drills and those kinds of tools. We've got other companies that are using it for prototyping of circuit boards. So again, fine detail, highly accurate color and placement. So there's a lot of really, really cool things that our machines are being used for. And I think the reason for that is that Mimaki has really been leading in a lot of technology where 3D printing, like 2D printing, is really about taking a material and getting it exactly where you want it, in the color that you want it, in the place that you want it, at the size that you want it. And we're taking a lot of that know-how from the 2D side and we're bringing it to 3D, right? So whether you're talking about creating models for architecture, or you're talking about medical, or you're talking about prototyping or final production of fine detailed parts, Mimaki has a technology that works for those needs.
Yeah, it's interesting. The scalability is the key there, right? So on the 2D side, a lot of the scalability is based off of the type of art that you're coming up with. So you could scale from a small production lot from fabric, for example, to a large production lot of fabric with the same type of file structure. You can do that with signage. You can go from a vehicle graphic to a vehicle wrap to a building wrap, if you will. There's a lot of different things here, but the scalability in 3D is very similar in that you can go from small, parts production all the way up to large production, and the learning curve ideally is not as steep on the 3D side as most people think, but is a little bit different than the 2D side. But even in general, when you get into these other applications, the scope of products you can come up with is so much more broad. Medical, for example, is a great example of that. It's something that most people don't think of when they're thinking of trying to go out and source new business.
Right.
There's a lot of places that could use exactly what you're saying from a medical perspective. They don't know where to source the stuff.
And I think it's a good point, because I think no matter what market someone currently serves, 3D and additive manufacturing is going to impact that market, right? And if you don't see that happening now, you'll be seeing it soon. And I think that stepping into the additive manufacturing world, and even if you're starting at the 3D FF222, right, as a beginning point, the skills that you'll learn, the ability to understand how 3D models are made, the ability to understand the terminology and the technology there, that scales up as well, right? So as you kind of get your feet wet and you get to understand how to move around in this 3D world, you can then take that and say, okay, now I want to add color, or now I want to add a large size to it. And those things that you're learning at that small size, they all translate. Right. And then Mimaki also has, as we talked earlier, about the 3D P3 software that's going to help you across any of those platforms as you learn to work with the files, you learn how to make things watertight, how to make things printable, how to add color to them. We're here to support you.
Yeah. So there's one other area that I've seen some pretty interesting stuff, and that's in the let's call it the display museum work. We've seen a lot of capability there, and I think that's really cool because say I've got a franchise business that's going out and they're opening a new location, and generally on the 2D side they'll source local work to do the printing for the magnets of the car, or the stickers that are going to go on the vehicles, or the graphics that are going to go on the walls in the facility, or on the windows, the floor graphics, all that. So that usually comes from a perspective of shop locally to manage costs and things like that. But on the museum side, it kind of complements it in the same way. I know a lot of museums are cautious about sending out artifacts that are very old. They're priceless in most cases, right? They can't be replaced. But you can replicate them with a three-dimensional workflow, and you can do that locally. So local sign shops or local print facilities that might pick up 3D that maybe aren't in the sign business can pick up work like that. And sure, it's more seasonal type of work, for example, but if you're picking up medical and you're picking up this, all of a sudden you're gaining more and more customers. And on the museum side specifically, I think it's really neat because now you can do these full-color replicas and not have to worry about shipping damage or losing the object or the insurance.
And yeah, it becomes an insurance policy in a lot of ways. So to be able to take an object, scan it, so you get not only the shape, but you get the color, you get the texture, all of that, and to be able to output it using a pigmented resin and end up with a very durable piece that, as you said, it can be shipped around. It can be a archive so that you basically have a physical backup of other objects. It also allows you to take something and be able to put it in someone's hands and say, hey, feel this this, turn it around where you wouldn't do that with an object that's hundreds of years old that maybe you only have one of. Right. So it's a really unique and interesting market.
And it's scalable too, right? You could run museums. So if you have a chain of museums, for example, that have multiple locations across any country, you could do the same display at those multiple locations simultaneously. Absolutely. Because you can get the job produced multiplied by however many locations you have. So that's really, really neat.
Absolutely.
So let's talk about the RC car project one more time. I know we have some footage of the RC car running. We're going to show the RC car. We're going to show the components, but we did a full-size model to conceptualize.
We did.
We've got that here.
So this is the nose cone from the RC car model. So this is a scaled up version of exactly what you're going to see in the small RC car. But this was printed on the 3D GD 1800. And once we knew that we had it in the geometry and everything the way that we wanted it, we actually took this, and because we were taking this model and we're taking it to trade shows, things like that, and we were shipping it, we added a little bit of fiberglass reinforcement in here just to give it a little bit more strength, because these walls are not super thick. And then as you can see, we also did full color graphics that we printed and wrapped on the piece as well. Yeah. Right? So this is a great example of tying together multiple technologies that complement each other to be able to get the scale of the 3D GD along with a full color print, and to be able to mirror what you're going to see in the smaller car.
So this right here, if we were only using the small format version of the RC car, and that was our intended purpose, this doesn't just have to be a prototype, though. You could also use this for a packaging point of purchase display as well.
Oh, absolutely, absolutely, yeah. I mean, this can be really anything that you want it to be. I mean, that's the great thing about 3D. So if this at this size, if you wanted to do POP displays, if you wanted to do architectural accents, if you wanted to do lighting, any of that can be done with this technology. And then based off of what is that next step, you know, if I only need it to be a basic idea of the shape, then the raw print is fine. If I want it to be able to, as we said before, to withstand weight or to be more durable, we can reinforce it a little bit, and then if I want to add color to it, I can do that as well. But the base of it is all happening with the Mimaki 3D printers.
Very neat. Well, we're going to show our guests some footage of the RC car and some of the production footage that we have of that on the 3D UJ2207, the 3D UJ553. Clearly, this came off the 3D GD 1800, and then the internal components, as you mentioned, were made on the 3D FF222.
Correct.
So we've got all of our technology on one really neat application. Yeah. And we look forward to that. So final thoughts on this as we go into the next thing is clearly we spent a lot of time on 3D GD 1800 today. There's a lot to talk about with 3D. There's some upcoming events that are going to be happening that will be beneficial for our viewers to join, that go into a little bit more depth. I don't know if you want to share some of those events that are coming up and what to look forward to.
We've got some partner events with Shapeways that we're going to be doing that are going to go into file preparation. We've also got some webinars that Mimaki is going to be doing that's just going to help people to understand the 3D workflow, whether it's a color workflow or it's a monocolor workflow, to help you see how to get into this technology and how Mimaki can support you.
Excellent. So go to mimakiusa.com, go to our events section. You'll get more details of when these events are going to happen and what they're going to entail. And we look forward to seeing you all at these different stages of your journey looking at 3D. And hopefully this has given enough information for our audience today to really understand how the 3D GD 1800 fits into our entire ecosystem of products and how it can complement their potential growth in the future.
Excellent.
Thank you.